Hello. Is this thing working? I think it's working. Cool. Ooh, look at that big camera. Alright, how's the hair looking? Good? Nice. Programmer hair. Beautiful. Yo, what's poppin'? What's up? What's good, everyone? How you all doing? Good luck today. You're gonna need it. Yo, come on. The stream just started. Why do you have to say that? Oh man, is day 15 really that bad? I haven't looked. I'm a little bit scared. We'll see. Probably gonna be one of those where like the first one's somewhat straightforward and the part 2 is gonna be impossible. That's my guess. I could be wrong. Maybe all of it's impossible. We'll see. Probably get started in a couple minutes here. Let people file in. Let's see. We're streaming on both Twitch and YouTube. Nice. They both look healthy. Nice. Cool, cool. Def, nice hair. Yo, appreciate it. It's funny, I switch between long and short hair. I had short hair before. I've just stopped cutting it for the last like 3 years. But I might cut it short again. And it's funny because the people I know in real life love that idea. They're like, oh, short hair would be so cool. But the people online who know me as the programmer, they want to see the long hair. People really trust programmers with long hair. So, oh man. Yeah, tedious is okay. I might eat these words. But tedious seems like it's okay. We'll see. Hopefully it's not. I mean, hopefully, I don't know. We'll see. We'll see. I'll just do it. That's all there is to be said about that. I really appreciate your bash videos. You show stuff which I haven't ever seen. Hey, that's awesome. I appreciate you saying that. That's awesome. I'm glad you enjoy them. I'm glad you get something out of them. There we go. Loved your abducted intellect rant. I assume you mean my AI rant. Yeah, that was quite the rant. That was during the day 13 stream. People ask me so many questions about AI and how I leverage AI to program and how it's changed my life, and I'm like, it just hasn't. But it's tough because yeah, I made that I cut up that part from the stream and uploaded it as its own video, and of course it's popping off. It's passion, it's frustration, it's engagement, it baits a lot of people into commenting. I knew that would happen, but I also knew that it would do well, so the video would go outside of my core audience, and then I would have people who don't know me making all sorts of assumptions, and it does get old, it does get annoying. People heard me rant about it, and their takeaway was that I hate LLMs and AI in general, and that I'm afraid of the future, and it's no, people were afraid of computers, and I'm a programmer. I'm clearly not afraid of that. An algorithm doesn't scare me. Oh my god. I don't know. They're just algorithms. That's not what does it. It's when it's just packaged up as on every website you go to, there's a chatbot, and everyone's like, oh my god, this thing's as smart as God. It's you're an idiot. This thing sucks. Just give me a human. Do you work in IT, or is it a hobby of yours? I work in the field, yeah. pretty much worked as like a mixture of like a software engineer and like sysadmin for the last like 15 years. So I work in the field. I have experience with that. It's also my hobby, so I just enjoy doing this stuff. Like, that's why I'm on here doing puzzles. So, yeah, I definitely enjoy it. All right, enough horsing around. Let's get started. There we go. Terminal view is up. And we are on, what are we on, day 15? Do both my titles say day 15? I think they do, right? I'm pretty good about that. Cool. Day 15, Warehouse Woes. You appear back inside your own mini-submarine. Each historian drives their mini-submarine in a different direction. Maybe the chief has his own submarine down here somewhere as well? Ooh. You can look up to see a vast school of lanternfish swimming past you. On closer inspection, they seem quite anxious, so you drive your mini-submarine over to see if you can help. Because lanternfish populations grow rapidly, they need a lot of food, and that food needs to be stored somewhere. That's why these lanternfish have built elaborate warehouse complexes operated by robots. Wow, convenient. These lanternfish seem so anxious because they have lost control of the robot that operates one of their most important warehouses. It is currently running amok, pushing around boxes in the warehouse with no regard for lanternfish logistics or lanternfish inventory management strategies. Darn. Right now, none of the lanternfish are brave enough to swim up to an unpredictable robot so they could just shut it off. However, if you could anticipate the robot's movements, maybe they could find a safe option. The lanternfish already have a map of the warehouse and a list of movements these robots will attempt to make. Okay, your puzzle input. The problem is that the movements will sometimes fail as boxes are shifted around, making the actual movements of the robot difficult to predict. Okay, I'm a little bit confused, but let's see. All right, so we have this like 2D grid, and then I'm guessing this is a list of the movements, like it said. So we have pound signs, we have O's, and we have an @ sign. Wonder if that's our robot starting position. Oh, there's a pound sign here too. Interesting. Okay, well. As the robot @ sign, okay, attempts to move, if there are any boxes O in the way, okay, so O are boxes, the robot will also attempt to push those boxes. Okay. However, if this action would cause the robot or a box to move into a wall, pound sign, oh, okay, nothing moves instead, including the robot. The initial positions of these are shown on the map at the top of the document the lanternfish gave you. The rest of the document describes moves. Up, down, left, right. Okay, the robot will attempt to make, in order. The moves form a single giant sequence. They are broken into multiple lines just to make copying and pasting easier. New lines within the move sequence should be ignored. Okay, cool. So it's multiple lines so we can read it easier, but it's basically just meant to be treated as one big set of instructions. Okay, it seems straightforward so far. So like if our robot attempts to move left, he'll encounter a box here. So he'll push the box and he will move left, I'm guessing. It seems like that makes sense. What if multiple boxes are next to each other? Does he push all of them? Let's see. Here's a smaller example to get started. Were the robot to attempt the given sequence of moves, it would push around the box as follows. So the first thing we do is we try to move to the left. Oh, but we would fail because we hit a wall. There's nothing to move. Then we would try to... Okay, this is where it fails because it tried to move left. Then it would try to move up. So it is able to move up. It'll try to move up again. It's not able to move up. It's bumping against a wall. It'll try to move to the right. So it pushes that box. Okay. Tries to move to the right again. Okay. So it does push 2 boxes. Okay. Cool. Move to the right again. It can't. There's nowhere to go. Move down. It can. Okay. So it can push any amount of boxes. Okay. This makes sense. So if I were to explain this in Minecraft terms, I'm like a piston. And these boxes are like dirt, and the walls are like bedrock. So we can push them, assuming there's no like limit, and we just can't push through walls. Okay. And there sometimes are walls that appear in the puzzle itself, not just the perimeter. I wonder if the perimeter is always guaranteed to have walls, or if we can just push things straight out into the abyss. This makes sense so far. Larger example has many more moves. After the robot has finished those moves, the warehouse would look like this. Okay, so here's what the larger example would look like. Okay, so it kind of just pushes all them, and that's where it parks. Cool, cool, cool. Let's take a second. Chat's popping off. Let's see. Could you make a video of you using Vim, maybe with keystrokes and or your top used keys? You're hella fast, and I'd like to get some new techniques and shortcuts. You know what? I will consider that. You are not the first person to ask me that. I've done a couple like small Vim tips, like shorts and stuff, but I should actually like sit down and make like a full length, like how I use Vim. I am definitely not the most like power user at it. Let me actually pull up a text edit. Let me just write this down. New document. Vim tips video. I'm just writing this down so I won't forget it. But yeah, I should. I think that'd be kind of cool. Like I said, I'm not an expert at it, but I know like enough to be dangerous. I think someone did make this in Minecraft. Yeah, it's like the first thing I thought of. This seems like very, very Minecraft. Or I picture like Link and Zelda Ocarina of Time like pushing milk crates around. Let's see. Cool. Give me a second. Okay. The lanternfish use their own custom goods positioning system, GPS for short, okay, to track the location of the boxes. The GPS coordinate of a box is equal to 100 times its distance from the top edge of the map plus its distance from the left edge of the map. This process does not stop at wall tiles measure all the way. Okay, so what its coordinates are, x and y, and the x is times 100. Then you add them together, and that's its number. Oh, okay. So this is just how we can determine its big final number that we submit as our answer to like, guarantee that we don't overlap with anything else, I'm guessing. The lanternfish would like to know the sum of all boxes' GPS coordinates. Okay. After the robot's finished moving. Okay. So, oh wow, there's a lot here, but this seems fine. Once we've run the simulation, we moved all the boxes in their final location, we have to go through, find the coordinates of all the boxes, calculate their GPS, which is just x times 100 plus y, and then sum all of those together. This doesn't seem that bad. This seems fine. This seems fine, right? Famous last words. So it looks like we have a couple different things of output we can use here. Okay. Let's start copying over some output. Where are we? Day 15. Cool. Let's Vim example input dot text. And this is the example from the website. You can't see it, but I'm copying it in. Then we have simple input dot text, because they gave a nice simple version of it that we can practice with and make sure that we're on the right track. So even the example has an example. And then we have real input, and I'm going to hide the terminal while I do that. Oh my god, that's a lot of instructions. Okay. Cool. So I guess to get started, we should just be able to read the data. That's what we can do here. So let's Vim part 1. While read -r line do done. Yeah. Let's just store the entire grid for now. I don't know if we'll need this, but we'll just store the entire grid as we read it in. This will be like our initial thing, although we can just, yeah, we'll keep iterating on this. So let's read this whole thing in. So the way we read it in is... read the initial grid. So what's going to happen here is if line is not set, we will break out of this loop, meaning that we're done processing the grid. because remember, the grid has a new line, a completely blank line before we start getting into the instructions. So we'll process the instructions in a separate loop. This will just keep it very, very simple for us. Let's see. I stopped at day 5, assigned to get back to work. Hey, you should. It's really fun. It's been super fun so far. I would say that day 13 was probably my toughest day. That was brutal. And even when I got the solution to work, I was like, I still don't fully understand why this works. But yeah, get back into it. It's super fun. All right, so now we're reading in this. So we know that the width is the length of the line. And when we get down here, height plus plus. And now that we have this, we can do for x equals 0, x less than width, x plus plus. I've written this logic a bunch. Done. We can say key equals x comma y, and the y is the height. You can say grid key equals the char. And the char is the string line substring at x for one character. So this is exactly what the character is in the map. So now we have the whole grid stored. So what does that get us? Let's go ahead and do what we always do. Let's make our print grid function. And print grid will just do a, I've written this so many times. For y equals 0, y less than height, y plus plus, do. For x equals 0, x less than width, x plus plus, done, done. Retab those, that's not right. Now that we have this, we can get the key, which is x comma y. We can get the character at that location, which is grid at key. And then we can echo dash n that, put an echo down here, and we should be able to print the grid. It's a lot of work here, but what this means, if this all works how we expect it, is that we should just be able to print just the grid. So let's see. Didn't work. Oh yeah, look at this. Just a typo. Hey, that looks like the grid, doesn't it? Cool. So, doesn't look like we did much, but we were able to read the grid into a new associative array and reconstruct it. So that's actually huge that we can do this. Let's see. Missed an X in the second for loop header. Yeah, good call. I noticed that as well. Luckily, the error message was pretty straightforward. Let's see. What can we do now that we can print the grid? We have to read the instructions and read the initial grid. Let's just move our functions up here. Read instructions. So what we'll do is we'll make instructions an array, and then we will read all of the instructions that we have to read. So we're going to read them line by line, but the new lines don't actually matter. We don't actually care. So we have to break each line into its own character. So we're going to actually read it character by character using this logic, and then we will store it in the instructions array. Instructions plus equal the character. That's what we're going to do now. So when we do this, we can printf. Actually, I think we can just do this. Separate it. Well, we can just separate them by spaces. Let's just do that. Echo instructions. So that's what the simple input looks like. When we run it, we should get the same thing. We get nothing. So our instructions are not quite right. What's going on here? Spelled wrong. That's it. Just spelled wrong. There we go. There's our instructions. As you can see, they're separated by spaces, but that's good. That means we're reading them into an array. So we now have an array of all the possible instructions that we need to run. If we were to run this on the example input, it should also handle that it's broken on new lines. Cool. That's awesome. So these are all the instructions that we have to run. At least we aren't in Rust yet. Yeah, hey, listen. We bring out the Rust when the bash isn't working for me. So hopefully we don't get to that point. Let's see. Okay. Oh, man. Neck is killing me. Whoa, that sounded good. I say we'll get into Rust within an hour of part 2. Listen, Dark Space. You might be one of the only people I trust with your with your guess there. But we'll see. We'll see. Alright, so we have this and we have the instructions that we have to do. So now we just have to loop instructions. So what I'm thinking is, here's what I'm thinking for now. Loop instructions and apply them one by one. So for instruction in instructions, do, done, echo, try, instruction. That's all we'll do. So this script will now loop through and try those moves. And now we just have to write the logic to actually try that. So let's make, try instruction. Cool. Nice. So now we just moved that into a function. It would help if I could type. Cool. Awesome. So what do we do now? Let's think about how we apply these instructions. If we move it to the right, so let's think. If it's a period, we immediately can move to the right. There's nothing else we need to do. Or any direction. If there's a period, it's the next step. We can just move there. If there is an immovable wall there, we can't move there. We're done. If there is an @ sign there, if there's an O there, then we may or may not be able to shift some things around. So if there's an O there, like if we try to move here, we have to look at what's beyond it. So, okay, we have to keep going. Oh, this is easy. We just keep going until we don't see an O. So once we see our first period or our first pound sign, then we know we're good. So if we only see O's and then a pound sign, nothing we can do. If we see O's and then we hit a period, then we know that we can take all those O's and move them into the period. So we basically just have to draw a ray in whatever direction we're going, so long as we find O's or periods. No, so long as we find O's. Until the first period or pound sign. That's what we do. We have to find the first period of the first pound sign, however many O's we encounter. Okay, yeah, I got this. I'm saying it out loud, but I think I got this. So let's do this. Let's do local new. Actually, we need to keep track of where the robot is, right? Yeah. So let's do, we need to keep track of the robot's location. If it's an @ sign, then we have the robot. So the robot location equals key. C equals dot. There we go. So what this means is if we see the robot, mark its location and treat that as an empty space. Cool, because the robot's technically standing on an empty space. So that's how we will accomplish this. We won't actually ever... We'll keep track of the robot's location, but the map won't actually have the robot in it. We'll just print him separately. So we're keeping track of like obstacles and sprites separately, effectively, kind of, as a way of envisioning it in your brain. Cool. So now we don't see the robot on the print grid function. We can add that functionality later, which we probably will. It'll get important, but not right now. So now we want to figure out the next place to go. So next location equals Let's do next x and next y. That's what we'll do. Cur x and cur y. This is where the robot currently is. So for cur x, all we have to do is we have to read in from the robot location, separated by commas, cur x, cur y. Cool. And then our next location will be determined based on the direction. So case instruction in. So the all possible instructions. This is, you know, up. If we're moving up, then next x equals, oh, you know what? Let's do this. Let's initialize them to be the current ones, and then we'll just modify them. So if we're moving up, all we do, if we're moving up, we lower the y. So the next y minus minus. And then we just have to do it for all directions. Let's see, if we're moving down, then the next y plus plus. Yeah, this seems fine. If we're moving to the left, and if we're moving to the right. Cool. So that's how we handle that. So echo, let's see, cur x, cur y, moving instruction to next x, next y. This is just to make sure that we're on the right page. Cool, so if we're at 2, 2 and we try to move to the left, then we would try 1, 2. If we're trying to move up, then we try to move this direction. Yeah, this all seems fine. Cool. So now we have to check what's there. So let's grab the character at that spot. Next x, next y. The grid at that spot. The nice thing about this is it will be unset if we're out of bounds, which I don't think we are. I think there's always a perimeter there, but we should still just check this anyways, like dash NC or exit 4. So if we exit 4, then we'll know that we've tried to step out of bounds. We never should, because even if you look at the real input, it's all pound signs around the entire thing. So we try to go out of bounds. Shouldn't happen. Cool. So now let's see. If C possible states is that it's a period, and if it is a period, this is really easy. We just store open, let's see, open space, we can move here. We just move there. If it's a period, we just move there. Really, really simple. And the way we do that is, let's think about this. Robot location, we just update that to be our key. So we've literally just moved the robot there. And we don't need to undo anything because we're not storing where the robot is in the grid. Nice. If it is a pound sign, immovable wall, we can't move here. Then we don't do anything. And if it is, this one's the big one. If it is a movable obstacle, we have to do something. So let me think about what we have to do here. If it's a movable obstacle, what we have to do, we have to try again. We have to loop. We basically just have to rerun this whole logic again. Until we hit a period or a pound sign. If we hit a pound sign, then there's nothing we can do. If we hit a period, then we can move it. So let me think about this. How do we actually want to write this? Because I keep thinking there's like different ways we can implement this. We could do like recursion. We could just keep like recursing into it. We could just re-loop this. Yeah, once we hit this O, now we're in like move mode. Let me think about how we would actually accomplish this. Yeah, the problem is I can think of a bunch of ways of implementing this, and they're all going to work. I'm just trying to think of which one would be the cleanest. The one I'm leaning towards right now is we keep going when we see an O until we encounter our first dot, and then what we do is we replace that dot with an O, and we replace the first O with the robot, replace it with a dot. We just swap the end and the front, and then we don't actually technically move anything. We've lost the integrity of the original walls, but it doesn't matter. We've just moved them into different places. So, still moving on. Respect. Yo, I don't know what you're talking about specifically, but if you're just talking about like advent of code, yeah, I plan on trying to knock out all 25 if I can. If I have to skip some or if some are too difficult, like I'll still, I'll give it a real honest effort. So yeah, hopefully it works out. Let's see. Yeah, you know what? Let's just start doing the logic here. Okay, so local num obstacles, maybe? No, I don't think we need to keep track of how many obstacles we hit. I don't know what we're going to keep track of yet, but we're just going to write some logic. We have next X and next Y. How about... Oh, this sucks. I'm going to regret writing this logic so dirty, but I don't care right now. Let's have final X, final Y. Terribly named, but... So, whatever direction we were trying to go in, we'll do this, and then we'll grab the grid at that key. And then we will check. If it's a wall, then we can't do anything. Okay. So if we hit a wall, we went through a bunch of obstacles, but we still ended up hitting a wall, there's nothing we can do. We gotta just break out of this loop that I haven't actually created yet. If we hit another obstacle, then we do nothing. I don't think we need true here, right? Yeah. And then if we hit a free space, and the way we push the blocks is that the grid at the final let's see, let's do grid at the next key. This is the one that's directly next to the robot. that one will become the robot. The robot will move there, but for now it'll just become a free space because we moved the thing out. The one that's at the final one, in this example, it's a period, so it's a empty space. It will become an obstacle. We've technically just taken the obstacle from the beginning and moved it all the way to the right-hand side, but like you could imagine that we shifted everything over. We actually didn't shift everything over. We just did like a neat little, like if you imagine a linked list, we kind of just detached it and put it over here, but like effectively that's what's going to happen. And the final thing we need to do is move the robot. So the robot location equals next key. That's it. I think that's it. It's pretty gnarly logic. Pretty gnarly logic, but we'll see. Okay, now I get it. You are using Vim. That's the reason why you still continue and cannot stop leaving. No, it's true. That's the reason I'm stuck doing this forever. I have no idea how to exit Vim. Don't pay attention to what I'm about to do. No one saw that. Okay. So there's a lot of stuff here. Oh, you know what? I'm not printing out the robot. So let's go ahead and add that to that. If key equal robot location, then this equals that. Okay, so the robot, let's see, tries to move left, nothing happens. There's a wall, tries to move up, it succeeds. Tries to move up, nothing happens. Tries to move to the right, it does push them. Tries to move to the right, it doesn't push them. Tries to move to the right, it doesn't push them. Okay, so that didn't work. Let's go figure out why that failed. We're going to be really good, and we're going to make sure we local all of our variables. I think I'm being good about that, but we can go ahead and just make sure. It's really funny. Oh, I said keep trying, and I said we're going to break out of the loop that we're in, but we're not actually in a loop yet, are we? Yeah. This is what we needed. We needed to just keep trying. This is some gnarly and not well indented code. I'm not loving this, but I see. Did it hang? Oh, are we getting into an infinite loop? Yo, what's up, Seeknight? How you doing, man? Welcome to the Twitch chat. Twitch has been a little bit dead over here, so it's nice to see someone there. Somehow we got into an infinite loop. Let's go ahead and add this, and then we'll just define fatal here. Hey, what's up, Chi-Town? How you doing? Where am I getting into an infinite loop? Oh, I see. I see. That just needs to be defined outside of the loop. That's because I just made a loop there. Okay, we at least finished now. That's nice. Oof. I like watching streams on Twitch better than YouTube. Besides, we need to get you a subscription button here so we can bury my Amazon, burn my Amazon Prime free subs. Yo, I appreciate that. Yeah, no, it's awesome. I like seeing more people like joining Twitch. Like it makes me feel like, you know, dual streaming's worth it. Worth it. I have to press one button on a piece of software. Oh my god. Be back at 15. Yeah, all good, man. Delete everything and try from start. Yeah, nice try. That's not gonna happen. What should the final puzzle look like? I'm going to pull it up in my web browser. I think the final puzzle, yeah, the final puzzle is supposed to look like this. So when we're done, we're going to have 2 at the top, 1, 2, 3, 4. 2 at the top, 1, 2, 3. Oh my god. It's right. This is right. So let's go ahead and copy over this. Vim, let's see, solution example. This is the bigger example. So here's what the solution, so we have the example puzzle, you know, here. Here's what the solution to the example puzzle should look like when it's done. So let's go ahead and run our thing. Cool. So does that final one look like the solution here? Oh my god, it does. It does. Did we write a really good working algorithm in under an hour? I think we did. There's a lot of prints there. It might not be, you know, super necessary to go and do that. I'll probably take those out before I ran it against the actual puzzle. Oh no, we don't even have the answer yet. We actually, there's still work to be done now. We just ran the simulation on it. We actually have to calculate some stuff now. Grid is ready to be processed. They use the GPS system. So we have to go through, find all of the boxes, and then do some calculations on them. Okay. This should not be that difficult. Let's go ahead and just steal the print grid logic. All right, so the key is that, the C is that. We only care about boxes, so C equals O, or continue. So if we are here, then we know calculate GPS coordinates for box. Okay. 1 from the top edge and 4 from the, let's see. I'm going to read this again. The lanternfish uses their own custom good GPS, blah, 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 blah. Say equal to 100 times its distance from the top edge of the map, plus the distance from the left edge of the map. Okay, 100 times y plus x. That's it. So score equals 100 times x plus y. Nope, 100 times y plus x. Cool, and then accum plus equals score. This is where we'll just add it all together. Let's define accum here. And then we'll say echo final score is accum. So if we run this against the simple solution, the sum should be 2028. Cool, we got an error. Oh, because we're not in a function, yeah. So this should be 2028. Oh boy, nice. And this one should be 10,092, 10092. I think we have a working thing. I'm gonna go ahead and get rid of the print grid while we try every instruction. So what we'll do is we'll just say echo before, echo after, and then we'll run it against the real input. You know, it's gonna go fast, but let's do this instead, or let's do this as well. Len equals, we'll get the length of the instructions, and then I equals 0. We'll do I plus plus here. We'll do it first, and then we'll say printf trying percent out of percent dot 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 r I out of len, and then we get down here, we'll echo. So what this will do is, you'll see what this does. Oh, it's because there's a function that actually prints stuff, doesn't it? Yeah. Let's make our functions not print. Okay, cool. We're good now. So if we ran it against the simple... Oh, it went so fast you didn't even see it. Oh my god. Okay. This is probably going to go fast enough where it's not even going to make a difference that I even bothered with that. Let's run the real input. Cool. There we go. Final score is 149 whatever. Let's take this. Let's go over to our browser. Put it in. Hit enter. Let's go. Let's go. Easy. Easy. Easiest puzzle of my life. I've never done an easier puzzle in my entire life. 1 gold star closer. That is what I like to see. Heck yeah. Heck yeah. Let's see. All right. I will be right back. Give me a couple minutes. I got a missed call from my mom. Let's see what's going on there. Did it unmute? What's going on? I don't know. This thing's weird. Cool. Everything's good. Let's see what we got going on here. Part 2. Let's see if dark space is right. The lanternfish use your information to find a safe moment to swim in and turn off the malfunctioning robot. Right, there's only one. Just as they start preparing a festival in your honor, reports start coming in that a second warehouse's robot is also malfunctioning. The warehouse's layout is surprisingly similar to the one you just helped. Oh, that's so convenient for us. Just as they start, let's see. Okay. There's one key difference. Everything except the robot is twice as wide. Oh, come on. The robot's list of movements doesn't change. To get the wider warehouse's map, start with your original map, and for each tile, make the following change. Oh, you gotta be kidding me. Okay. If the tile is £, the new map contains £, twice as wide. Okay, so not height too. Okay. If the tile is 0, the new map contains bracket. If the tile is period, the new map contains period. And if the tile is... Okay. This will produce a new warehouse map which is twice as wide and with wide boxes that are represented by £. The robot does not change the side. The larger example from before would now look like this. Oh, wide boxes. Ugh. Okay. Because boxes are now twice as wide, but the robot is still the same size and speed, boxes can be aligned such that they are... Oh, you gotta be kidding me. Okay. Because boxes are now twice as wide, but the robot is still the same size and speed, boxes can be aligned such that they directly push 2 other boxes at once. For example, consider this situation. After appropriately resizing the map, the robot would push around these boxes as follows. Okay. Oh, God. Oh, yeah, just representing this is going to suck. The warehouse also uses GPS to locate the boxes. Fine. Okay, so it's just another GPS calculation. To the closest edge of the box in question. Okay, so whatever the left side of the box is. You can do it, man. Yo, thank you. I appreciate it. I will be able to do this, but Darkspace actually said it perfectly. This is just tedious. That's what this is. It's cool. It's a neat little twist, but yeah. Okay. So let me see if how it's represented here is how I want to represent it. Because this is already leading me down the path to double the width. I'm wondering if it makes sense to just treat widths as half step movements. That could be way off here. No, it's probably not ideal to do it that way. But then it would allow me to keep treating the boxes like they're one thing. No, I think we need... Yeah, I think this is okay. I think I still treat everything like it's one block. But the boxes, I'll just be aware of the fact that for every block that there's a box, there's also a spot to the right of it that's considered part of the box. Yeah, the part that sucks here is pushing something upwards. So like, I'll show you what I mean. Vim this sucks.txt, because I want to make sure I'm right here, and I think I'm right. If we have like, let's just draw like a little example or whatever. All right, so we have like this little example. If we have like my robot's here, we have a box here. When the robot pushes that up, it should move all of the boxes up, right? Like, I think that's the case. Yeah. So, like, technically the amount that it could cascade out, it's only one in each direction, but, like, yeah. I mean, this situation, this won't ever be the start of the map, but this is just a contrived example of what it'll be. I don't know. Let's just jump into it, right? All right. Let's just get the data read in. No, it has to be up here. Okay. Here's what we'll do. Yo, what's up, Don? I did 1 day and a half of AOC on New Year's Eve. Hey, that's fun. It's a fun puzzle thing. Absolutely waste on alcohol. Well, that's a wild way to experience it. Did day 2, part 2, and cannot do it? Well, don't give up on AOC then. There's still other puzzles you can do. Like, I've definitely encountered later puzzles that were easier than some of the earlier ones I did. So definitely don't worry about that. All right, so if we encounter a pound sign, then we will set grid at key left to be a pound sign and grid at key right to be a pound sign. If we get a box, then we'll set this to be an open bracket, close bracket. If we get a period, we will do the exact same thing here. And if we get this, which is the robot, then we will store the robot's location as key left, because that's where it starts. And then we will set this to both be empty spaces. There we go. And then let's just exit here and run part 2 with the simple input. Syntax error, nice. Oh. And then 120. Is there still a syntax error? I don't think so, right? Yeah, okay. Yeah, this should just work. Yeah, okay, we have the right width and the height. So something's weird. Figure it out in a second. Let's see. I think I can go further sober. Yeah, I believe you probably could. Why not use Rust? Because I'm doing it in Bash. That's why. My challenge is to do it in Bash. If I get bored or stuck, I'll switch to Rust. But I like doing it in Bash. It's trying a language I've never used before. Yeah, that can be tough. Any reason you use Vim and not NVim? No real reason. I've just been using Vim. So like, you know, NVim came out later and I had no real incentive to use it. Vim just works for me and gets the job done. Are we printing anything out there? What's going on here? I think I have an idea of what's going wrong. I think it's the reading in data, right? Yeah. Read initial grid for X in line. Yeah, this is what's going on. We need to loop the line. But then where we store it is not X comma height. It's X times 2, right? Yeah, I think that's what's happening here. There we go. Okay, that looks good. And that's the simple one. It looks like they gave me... All right, I'm looking at their simple example they gave me that I could follow, and it looks to be different. So let's call it Vim simple part 2.txt. This is what they gave me there. So I can do simple part 2.txt, pipe it into part 2. Okay. And that looks right based on what they have. And then it shows me how it should work. Okay. So now that we have that in there, let's go up to our box pushing logic. Okay. So if it's either of these, then we know we can push it. This is tedious. Tedious is a great way of describing this. Yeah. Let's take a little mental break, huh? There we go. How's everybody doing tonight? Cool. We're good. Let's get back into it. Yo, what's up? Welcome back. How you doing, man? Let's see. Yo, what's up, Dave? How you doing, NNBB in the YouTube chat? Chilling, I hope. Let's see. Going great, man. I hope you're good as well. Are you still off from work? I am back on Monday after being off from the 19th. Listen, same. I go back on Monday after having 2 weeks off, and let me tell you, oh, God, I do not want to go back. Oh my God. Listen, when I get Twitch subs up and running, if I can just, if everyone can just pay me $1 million, I can quit my job. That would be ideal. That should be everyone's 2025 New Year's resolution, is to get me unemployed. Dude, I feel that though, man. I love having time off. Oh my God, I never want to go back after it. Samesies, yeah, man. Dude, I feel that so hard. All right, so let's lock in. What are we going to do now? Now that we have this new map, and here's our robot, when we push things, we need to actually be smarter about how we push things. We could approach this one thing at a time. Here's what we'll do. Oh, it's going to suck, because if we're pushing from the left or the right, oh man, yeah, this stinks, because they're wider than they are tall. We might actually have to have some really specific logic. So hear me out. If we're pushing from the left, we're going to encounter a right brace first. If we're pushing from the right, we're going to encounter a left brace first. If we're pushing from above, we don't know which one we're going to encounter, but which one we encounter lets us know what direction it's in. Yeah. I think we have to do some work, which is fine. Do they force you to write Perl at work? Nah, not too much. I have had to write Perl for work, though, before. Definitely something I've had to do. How are we going to do this? Let's think. How do we want to do this? This is tough. I think we have to think about the directions we can approach them, and that might change how we do it. So we literally might have to have code to handle the 4 directions, or at least 2 directions. But let me think about this. All right. Just gonna write out some code and we'll see what we feel about this. If we're trying to move into a movable wall So it's either a left square bracket or a right square bracket. Doesn't matter which direction. Well, it does matter which direction. If we're trying to do this, then we will run try move walls up. We'll figure out what makes sense. And we'll have 4 different functions for this. This is super excessive. Very tedious. But I can at least start to make some progress. Cool. So if we try to move walls to the right, then we know that our current, yeah, we can do this. We can get our current X and our current Y from the robot's location. And we know that we're trying to move to the right. So our next X is current X minus 1. No, plus 1. And our next Y is just our cur Y. So we know all this stuff, which is nice. So if we're going to try and move it to the right, we know some things that can happen, actually. This is very nice. All right, so if we hit a wall, then we can't do anything. If we hit a free space, then we can move there. Wait, no, no. What am I doing? We're never going to hit these. Because we already know that we hit a square bracket. So if we're trying to move the walls to the right, then we know that we were moving to the right. Yep. And we encountered a square bracket. So we can do an assert here. We can assert, since we know we're moving to the right, we can assert that the character is a left square bracket, because that's what we should encounter. Just exit a random number. Let's do this. Key left. Key right will be next X plus 1. Probably we should keep track of how many walls we encounter. Okay, now we need a loop. Now we just need a loop. This shouldn't be too bad. Do a while loop. Get the key left, key right. We'll assert. No, we shouldn't assert. We don't actually know that. Okay, I think we're onto something. This looks a little bit scuffed, but we should be okay. All right, so if it's a wall, then we will try again. If the next immediate thing is a pound sign, then return. We can't move this. If it's a left square bracket and a right square bracket, then we try again. It's a free space. Then we can shift everything. So now the shift logic is going to be a little bit scuffed, but what we have here, we know what the next one is, and we know what the final one is, so I think we just need to rewrite them. So robot location equals next x comma next y. Grid at next x next y is a dot, and then for x equals next x plus 1, x less than equal final x, x plus plus, do, done. The key is x comma y. Nope. Yeah, it is. X comma cur y. It doesn't matter. The y never changes. And the character that we're going to use is either going to be a left square bracket or a right square bracket, and it alternates. So we can just do yeah, we'll start at a left bracket. We'll set grid at key equal to $C, and then we will set there's cleaner ways to do it. I was thinking like just have a counter and do modular division. I think this will work. I think this will successfully shift everything to the right. Which means to move things to the left, we would basically just do the same thing. But let's do this. CP simple part 2 to dave.text. So now we have our own little simple map, and we can try to move things to the right. So we'll do that by putting the person here, and we will just do right. Cool. So if we cat Dave, and then we run it through part 2, syntax error. What was it, 52? Oh, I wrote else. Elif. Okay, and then I have it exit, right? Yeah, okay. Got an infinite while loop. Okay. If left is a pound sign, if left is the brackets, left is a period, else just break. Okay, so we keep trying to push to the right, and nothing happens here during this logic. So something is broken. Cool. We're making progress. So we're going to try to move to the right. The way we're going to do this, we're going to get the next x, and we're going to store something called the final x. We get the key at the left side, the key at the right side. If the key at the left side is a pound sign, there's nothing we can do. If the key at the left side is an open square bracket, then we move forward 2. If the key at the left side is a period, then we shift everything. And if the key at the left side is here, echo, how did we get here? LOL. Echo, next x equals next x, final x equals final x. Why are we just stopping at 6? C left is this, and C right is that. That should never be the case. Okay. C left is this and C right is that. Next x is 6. Final x is 6. 0, 1, 2, 3, 4, 5, 6. Oh, well, it'd help if these were y's, huh? Maybe it won't help. When we try to move the wall up, We get a next X and we get a final X. Okay, so we read the robot's location. That's our current location. The next one is the current location in 1 in the X direction. That's good. And the final X we initialize to be whatever the next is. And the final is the one that we constantly change. Oh, well, help if I actually use the variables, right? Okay, well, we got into an infinite loop. Okay. Once we shift everything, once we do all this work, then we need to return. Okay. He's trying to push in there. He's eating them. Definitely eating them. Cool. So we at least got him to move there. We encountered a period at the final location, so we got the robot's location, move him over, set the grid at that location to be a dot, and then we have to go through and reset all of the rest of the grid. Yeah. Setting 7.3 to this, setting it to that, setting it to this, setting it to that. 1, 2, 3, 4, 5, 6, 7. No, it's 0 indexed. Zero, 1, 2, 3, 4, 5, 6, 7. Yeah, it's not being set. It says it's being set to that, but it's not being set to that, right? Oh, look at this. Ready? Associative arrays and bash. Oh, man. This is brutal. Hey, look at this. We pushed them. We pushed them to the right. We were able to push them to the right. And we should never get the how did we get there message. Okay. So now, like a true good programmer, we're going to copy and paste some code. Try move walls left. -1. This is actually going to be off by 1, isn't it? Yeah, we'll have to just make sure we get all the directions correctly, or correct, but it's fine. No, we start at this one because we're moving to the right. And we start at next x -1. X is greater than or equal to final x, x minus minus. Cool. I think now we can push things to the left. So we can test that with Dave.text. Let's move the robot over here. Let's change all these to lefts. Cool. So now if we rerun the same thing, cool, it looks like it actually pushes it to the left. Wow. This is ridiculous. Oh, and when we set the score, we can actually just fix the score logic right now. I know it's not important, at this very moment, but I think the score logic, we just calculate it from the left-hand side. I think that's all it was to calculate the score. So we might as well just like update it. Okay. So now we can move things to the left and we can move things to the right. Now we need to handle moving things up and moving things down. Okay. Not bad. Let's figure out how we're going to do this. Try move walls up. Okay. How would we do this? We have our current X, our current Y. Our next X is cur X. Our next Y, because we're trying to move it up. To move up, we have to go in the negative direction. Okay. Now, a couple things can happen here when we try and move it up. That sounds like an Apple keyboard, am I right? You are absolutely right, my friend. That's what I'm rocking. In the Twitch chat, let me throw subs at you, Bash Wizard. Hey, I'm trying, okay? In order to become an affiliate, I have to stream a certain amount of hours, I have to get a certain number of followers, and I have to stream a certain number of days in a week. I got the followers. I got the hours. I just need the days of the week. I think I have to stream at least days in a month. I think 7 days in a month, and I think I've gotten like 3 or 4. So, yeah, don't worry about it. You'll be able to sub soon. Looks good and well done. Yo, appreciate it, man. It's not an Apple computer. It's an electric one. Listen, I don't even know how to respond to that. Let's see. YouTube did not let me send this. Doing my little part now and encourage everyone else. Watch the stream both on YouTube and Twitch. Help Dave's channels grow so he can make a living by doing content full time. Yo, appreciate that so much. Yeah, and don't feel pressure. Don't like put me on in like 10 different screens and idle. I actually don't even know how much that'll be. If you want to watch me, go for it. Just watch on whatever you want to watch on, whatever you're comfortable with. I'm on Twitch. I'm on YouTube. The moment I'm done being live, this YouTube live stream will become a VOD. It's publicly accessible. Anyone can go back and rewatch it with the YouTube chat replay, which is super nice. I then go through and cut these videos up into more edited content where I cut out parts like this where I'm talking to chat. So if you just want the advent of code stuff, you totally get that. So I double and triple and quadruple dip in there. Then is there any other way I can throw support? Patreon, Ko-fi? Sure. I mean, if you want to, hey, I'm not going to stop you. I appreciate it so much. A couple people on YouTube have thrown in super chats, which is super nice. I think that's equivalent to like bits on Twitch. Although bits, you pay for bits and then you give bits and then they turn into money. Super chats are more direct. It's like this person, chatted for $10. A lot of people do that. I do not have a Patreon. I'm thinking about doing one. I do have a Ko-fi account, but don't expect any sort of special paywalled content there. It's literally just because people wanted a way to donate to me. And I didn't really figure out how to get PayPal set up working. So like, I just created a small little Ko-fi account. I even literally say, I'm like, there's no paywalled content here. It's just for people that want to subscribe or pay money, one-shot donations. So yeah, I mean, I definitely have a Ko-fi account. Feel free to check that out. It should be linked somewhere, something. If not, let me know. But don't feel pressured. You don't have to drop anything. And if you want to do it like more anonymously, let me know and I won't look at it during the stream. But if you're like, yo, I threw you something, go check it out. Oh yeah, I'll take a look on stream and I'll call you out and I'll thank you and everything. So you just let me know what you like. If you like the public call out or you actually would just prefer to remain anonymous, your call. Yo, what's up, Blazer Gamer? How you doing, man? Welcome to the stream. Let's see what we got. What are we doing? We are trying to move the walls up now. Doing good. Yo, that's good to hear. Oh, yo, check it out. Yo, ARX Aaron. Let me know if I'm pronounced that correct. Maybe it's ARX Aaron. I have no idea. ARX Aaron with the $10 super chat. Let's celebrate their first super on a live stream. Yo, appreciate that. Thank you. I can't believe that I am your first super chat. That's very exciting. Also, I can't believe YouTube tells me that. Yo, that's sick. Appreciate it so much. Like I said, guys, please don't feel any pressure to donate. Like, I make some money off ad revenue. Not a ton, but like I make money that way so my content can be free. If you want to, hey, I'm not going to stop you. But yo, I appreciate it. Like, really, that's super cool. So thank you so much for the $10 super chat. That's dope. Now we got to figure out how to move the walls up. So while we're here, we will look at the key, which is directly above us, and we will check what it is. So we can do a nice little case statement. Oh my God, another super chat. Yo, what's up? I don't know how to pronounce your name. Is it Jason? Let me know how to pronounce your name so I can do it correctly. Because if I just read it phonetically, it's Jason Hyde, but I feel like it could be pronounced something different. So let me know if I'm mispronouncing it. I don't want to do that. But thank you so much for the $10 super chat in YouTube. Heck yeah, that's awesome. You are my favorite combo of nerd music and internet humor. Keep it up. Listen, man, that's awesome. What a compliment. What a compliment. We'll def go Patreon if you decide that works for you. Yo, appreciate it. Yeah. I want to do something like that. I have a rule. I don't want to paywall educational content. So like these streams, the videos I make, all of that stuff will always be on YouTube. Like you can go watch it. If I did a Patreon, it would be things like special Discord channel, maybe like a monthly like Discord call that we could all hop in or something. Maybe for the higher tiers, I could throw your names at the end of a video or something like that. Be able to ask me a question once every whatever, and I'll record you a video and upload it to my socials like directly, because I respond to people's comments on Instagram and stuff and upload them, but whether I respond to your comment or not is kind of up to how I'm feeling. But if I did a Patreon and people were paying me, it's like, oh, I'll respond to your stuff, yeah, no matter what. So if I do a Patreon, it would be like that. No current plans, but it's always in the back of my mind. Let's see. Oh yeah, we're doing day 15 of Advent of Code. Let's see. Jason. Okay, cool. So I'm pronouncing it correctly. Family members enjoyed Han Solo's son from the comics. Yo, that's dope, actually. That's sick. Let's see. Arx Aaron or Arex or Eric's Aaron. Okay, so I'm going to call you Arx Aaron. I like that. Amiga fans will understand. Well, listen, I don't quite understand. So hopefully your people are somewhere in this chat. All right, so what do we got going here? What do we got going on here? Also, how do people feel about that Patreon thing? Like if I were to do something like that, like I said, all this content will always be available for free. Don't worry about that. It would literally just be additional stuff would be Patreon. So it would be, like I said, you know, special Discord channel, maybe like a monthly call where like top level people could just like jump in and we can just like hang out or whatever. None of this is set in stone, but it would just be like stuff like that. Maybe some behind the scenes stuff. I have no idea. It's tough because in my mind, I'm like, who would want to pay for this? But I get people that like message me like, yo, I want to pay you. And I'm like, who am I to say no? Oh man. All right, let's see. Okay, cool. I don't know what this is, but I'm making a Monster Hunter-like, but only dragons and more fantasy. Wait, are you making something, or are you saying you don't know what this chat is? Or what this stream is? Not quite following, but if you're making something, that sounds pretty cool. All right, so we're going to try and move the wall up. So what we do is if the C is a pound sign, then I'm recreating the logic. I'm literally recreating the logic here, but it's fine. It's fine. If it's a pound sign, then we can't do anything. LF, this could be a case statement. I don't care. If it's a period, then shift everything. LF it's a this, or it's a this, then we are going to push this. Okay. Okay, cool. This all seems good. Just wanted to see what I'm making. Okay, yo, that's sick, man. All right. This is going to be annoying. This is definitely going to be tedious. How do we handle this? Yeah, we'll have to figure out. We'll have to figure out how to do this because it's gonna be tough. Because we have to move everything up, and we could be bumping into other things, and they can cascade. They can cascade out. So this will be interesting to do it. Also, yeah, if you're watching on Twitch and you enjoy what you see, go ahead and hit that follow button. It helps me out. I have no idea if it helps me out. It's cool to see that number go up. If you're watching on YouTube, go ahead and hit that subscribe button. I got like over 100 subscribers in the last day, and that was pretty cool to see. My goal is to hit 100K so I can get that, silver play button, because that thing looks pretty sick. So if you're liking the stream, go ahead and hit the subscribe button. If you're here to watch the stream, you're probably already subscribed, so good for you. Good job. My comment is curse the stream with you saying tedious every 5 minutes. I know. It's gotten under my skin. Like it's in my subconscious now. It's such a good word to describe it. It's not like nothing has been show-stoppingly hard. It's just like, oh, how do I actually represent this? Like this is something. Okay. So, if we're gonna push something up and we encounter we're gonna this function's gonna branch out. I think we might need recursion, and we might need to keep track of what we need to move. I don't want to overcomplicate it right now. But if we're here, yeah, this function's going to have to be recursive. Let's just start writing down some logic. I think these should be separate. Just for my own understanding. If we have this square bracket, then we know that we are trying to push this and the thing to its right, because the block takes up two things. So all right, so we know what the left and the right thing is, and then we need to cascade up while keeping track of everything. This sucks. I might use global variables just to avoid some of this stuff. Let's think. We have a left and a right. If at any point we encounter a pound sign, we're just done. There's nothing left to do. If any part of the cascading walls are affected by an immovable wall, we don't like bend around it. We just give up. If we encounter a period, we don't necessarily shift everything yet. We just don't return from the loop. And we keep going until there's nothing left to check. Yeah, this is gonna be something. Okay. We're going to make up some stuff. I'm going to make a global array here. None of this is going to be the dirtiest code in the world. Okay. So we have a left and a right. Now we need to just making up some syntax here. We could have like an inner function that we call recursively, where we call it with we call it twice with the left and the right, because we're going to branch up in those directions. And if we do it this way, clear out this array. I really have to think about this, because I'm mixing recursion and infinite while loops. This is not an ideal situation to be in. I have to decide if I'm going to be doing depth first or breadth first here. I think depth first probably makes the most sense. Love your channel. I'm your oldest fangirl. What a fun comment. Heck yeah. Welcome. Glad you're here. Glad you enjoy it. I'm your oldest fangirl. Now, does that mean you're old or you've been watching me since the beginning? Or both, I mean. I don't know what I want to do here. I'm trying to figure out, like, I have a rough idea in my head how this should work, and I just need to figure out how to implement it. Because I think we got a depth first here. We recurse into it. And the moment we hit a pound sign, we're done. We are absolutely done. We need to short circuit our way out of that. I think we need to, yeah. I think we need to lean on the fact that in try, move, walls up, we know that it's a left or right bracket. So if we lean on that fact, we can make our inner function. If we have our inner function, there we go. Okay. This should never happen. Okay. So now we have a function called try move walls up. And then we'll check. And then we'll have this actual function that does the work. So we're calling it the inner function. And this will be the thing that checks, like if we'll get the location there. Figure out what this is. If C is a period, then we can move. Just drop out here. We'll just return. We'll return 0. I hate this. I hate this. I am ancient. Oh my god. Hey, that's cool. Welcome. Glad you enjoy the content. I hate this. I hate the way I'm coding this. Let's do this. We'll assume can move up equals true. We'll assume we can move up. And then if we get here, if can move up, then shift everything up. That's what we'll do. And then in here, we don't need to do anything because it's a period. Elif C equals £, then can move up equals false. There's nothing we can do. We can return. We're still going to check everything else. It's a little bit tedious, but as long as this Boolean gets set, if you think this is bad, you'll think mine is monkeys on typewriters. Dude, this feels so gross. Like this solution just feels so gross. Like, I'm not even kidding. I feel like importing this into a game engine would be easier to write the logic than this. Glad to see I'm not the only one who struggles. Yeah, some of these problems are just really tough. Is there any way you can simplify the problem and solve the simpler problem? That's exactly what I'm doing. I'm taking very simple inputs. So I've already done that. Don't worry. I am breaking this into how can we push things in one single cardinal direction and handling all 4 separately. Like, I'm already making this almost as simple as it can go. The simplest thing would be to get Legos out and just start pushing things around. Just found your channels on New Year's Eve and I've been binge watching. Yo, appreciate it. Yeah, hope you enjoy it. Hope you like what you see. Yeah, a lot of fun stuff. I also post on Instagram. Big following on Instagram, so a lot of fun stuff there. But most of the content you'll see on Instagram, you will see on YouTube and stuff. YouTube will have like the exclusive content. Hello, Bashers. Yo, what up, Travis? How you doing, man? All right. And then, oh yeah. Oh my god, this is it. This is it. Wait a minute, this is it. This is it. This is it. I already have this logic here. If it's a square bracket, then we just do this. Oh my god. This isn't terrible. This is just depth first with recursion. This is it. Now, okay, hold on. I say this is it. This is it, but we haven't actually stored any of the information. We've just gotten a Boolean that says if we can and if we can't. I think this is where the to move. It was to move. I think this is where to move came into play. Wait a minute, what am I doing? What am I doing? Oh my god. We don't need final. Oh my god, we're getting there. We're getting there. We don't even need this. We just need the inner. Oh my god. Okay, this is getting easier. It's getting easier. There we go. So now we'll have a Boolean that lets us know if things can be shifted up or not. We can test this. Dave.text. So let's go ahead. Put a wall here. And then put my robot there. And then change it to up, up, up. So if we run cat Dave pipe into part 2. Syntax error. Nice. All right. Yeah. There we go. Okay. So according to this, we can't move up, we can't move up, and we can't move up. That is incorrect. We should be able to move up. So this logic is incorrect. But that's okay. We will figure out why. I think that's the only place I set it to false, right? Yeah. What am I incrementing here? Oh, yeah, look at this. This isn't right. Wait, this is right. Hold on, what are we doing? Yeah, we get the next one. We have to get the next Y. Yeah. Yeah. Can't move up. I know we can. So what do we do? We're the robot. We look directly above us. And we check to see what character was there. And we keep saying a pound sign at 6, 6. That should not be a pound sign at 6, 6. Something is wrong. Yeah, right? What's going on? Three, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. Okay. It is a pound sign. Why are we checking 6, 6? 6 comma 3. That looks right. Yep. So why are we trying 6 comma 6? Am I mixing up x and y? Am I using x where I mean y? I almost certainly am, if this is happening. Cur x, cur y from the robot location. Cur x, cur y minus 1. Next x, next y. Next x, cur y. Just be next y, but that wouldn't change anything. This is still going to have a problem. I'm wrong. In Minecraft, whatever I was about to say. In Minecraft. Come on. When you see it. Yeah, I saw it. Hey, this looks way nicer. Can move up. Can move up. Awesome. So it knows that we can move up. Don't try and do it 3 times. That's just a lot of printing. Let's just try and do it once. So we know we can move up. If we change this to put a pound sign here, then we can't move up. Can't move up. Nice. If we change this to be another obstacle, we can't move up. Amazing. Incredible. Beautiful. Cool. So now that we know we have a Boolean that lets us know if we can or can't move up, we need to keep track of what we are actually moving up. The way we can do that let me think. We just have to keep track of, yes, let's keep track of every obstacle we see. And keep it in an array of toMove. This is ugly. It's very ugly. I don't like this. I never code like this. Trust me. I'm a way better programmer than this, I swear. toMove. Every time we encounter something here, we will push it in the toMove. So we know that this, if we have a square bracket here, then the key x comma wait, what are we doing here? No, this is right. This is right. Yeah, if we have a left square bracket, then we will push key equals x comma y to move key equals 1, and then the next key is x, because this is the left side, plus 1. We will also retain this, so it'll filter out duplicates nicely. This will just be the opposite. No. Let's not store both. Not store both. That's stupid. Let's just store only the left square brackets that need to be moved. So each block will be identified by its left square bracket that will need to be moved. So once we know that we can shift everything up, for key in toMove, do value equals toMove key. Actually get the keys, echo, we need to move key. We don't need to get the value of it. Let's put them down here. So now every time we can move up, we know that we need to move 6 comma 2. So this is the wall that's at 6 comma 2. So 0, 1, 2, 3, 4, 5, 6, down 0, 1, 2. So we need to move that. I think we're good. I think we're making good progress here. I mean, it's tiring and it sucks, but you know. I have to bail. 1 a.m. here in England. Good luck with the rest of the solution. Yo, appreciate it. Thank you for stopping by. It's awesome. It's awesome people want to jump in here. Oh man, if I could quit my job and turn content creation to a full-time job, I would totally stream earlier too. Okay. We know what we need to move now. Okay. So now that we know what we need to do, let's think about how to do it. Here's what we're going to do. This is easy. For every key that we need to move, we will go through and set them all to periods, and then we will set the y-1 version of the keys after we do this to left and right square brackets. Yeah, okay, we're good. Okay, so now we can do key equals x comma y, grid at key equals dot. Clear the existing walls. Put them back. Shifted up. Fuck yeah. Oh my god, this is gonna work. All right, let's do this. Now we need to read the x and the y. We need to do y minus minus. And then we need to set this to this. Oh, you know what? We also need to get the one next to it because these are the left square braces. Key equals x plus 1 comma y. Grid equals this. Oh yeah. Oh yeah. I think this is gonna work. It moved the wall up. It moved the wall. Okay. It moved the wall up, but it didn't move the robot. But that's okay. Because once we know we can move up, the last thing we can do here is move the robot. Robot location equals wherever we currently are. Next X, next Y. Are you writing a NetHack-like game? I have no idea what that is. I am doing a puzzle challenge called Advent of Code, and there's all different puzzles for different days, so that's what I'm working on here. So Advent of Code has these like really fun puzzles. I'm on day 15 of it out of 25. It's like an advent calendar. It is an advent calendar. So that is what I'm working on. All right, so I think we're making progress. Can move up, and it moved it up. Okay. So now, ugliest code I've ever written in my life. We have functions for moving up. You know what that means. We're going to need functions for going down. Try move walls down. And when you're moving down, you're going in the plus direction. Dave, couldn't you factor this out into a function and not have to hard code everything and duplicate code? Yeah, I absolutely could. I'm not going to, but I could. Now the inner one is the one that we care about. There we go, the Y's. That's it. That's it. Now we can move in all directions. There's still a lot of printing. Okay. Is this real or pre-recorded? Does that answer your question? Let's see what we got going on here. So in this part 2 example, okay, so in the part 2 example, what did I save it as? I should get a... Let's see, I should get a GPS coordinate of 9021. Zoni says, hello. Yo, what's up? How you doing? I have so many example texts here. What do I have? Simple input. Simple part 2. I have example. Let's try the example. Cat example pipe into part 2. Oh, that's a lot. Well, we're getting some how do we get here. How do we get here's. So that's not good. What are you working on? It is called Advent of Code. It is a series of puzzles that you can do, programming and kind of like math puzzles. And that's what I'm working on. I'm working on day 15, part 2. Okay. So when I run this, I just get some bad logic. Okay. Well, let's just do this. We get the bad logic 400 iterations in. Okay. Exit 4. Okay. Yeah, this should never happen. So what happened here? Oh. -1. How do we get to -1? That's crazy. We should have never even been able to walk over there. The grid should have prevented that from happening. All right. So we are here. Okay, yeah, the grid's broken. We are pushing walls out of the grid somehow. Yeah, we're something's being eaten here. I should find a... Did you get box into a pound? I have no idea what happened. We're going to find out. Whatever happened, I'm going to try and recreate it in a very small test. I'm surprised you haven't split a box in half yet. I think I did split a box in half. The flashing is annoying. Oh, that box just got split in half. Yeah, some of these boxes are just being destroyed. I wonder how. So you're up? You think so? I'd have to see it slower to see when it happens. I know that input all too well. It looks good. Nope, right there. It just got eaten. Yeah, I just watched a box disappear. Oh, yeah, look at that. Something's happening there. Things are getting eaten. CP example to dave.text. Vim Dave. It was like... let's put the robot here. And then try to push, like, up, I think. Let's stop clearing the screen. All right, I was able to push it up. Yeah, I'm pushing up just fine. I wonder what happened. Ah, I just overwrote it. That's annoying. Okay. Yeah, it just got eaten here. Yeah, I tried to push it up and it just got eaten. Wait. I think I have an idea. When I try to push up, like I encountered this, so I know that I check up here, I check up here. I have to walk through my up logic, which means it might be in my down logic as well. We read the robot's location, and then we decrement y, and that tells us what we're looking at. Then we call this inner function to figure out what we're looking at. So the inner function, we look at that. If it's a period, then we know we can move. That's not right. Well, hold on. We know it's not going to be a period for the first one. It's going to be a square right bracket. Hold on. Yeah, because this is, okay, this function already moves us up and then checks. So we're not at the robot's location. We are already potentially in a wall that half exists. I think that's wrong. Yeah, I think we just want this, right? Oh, we don't want that. Now we're just eating things. All right, so we know where the robot is. If we try to look at the robot's location with inner, what does inner do? Oh, inner just grabs it there immediately. Right, yeah, that's not going to work. No, it is, because it'd be a period. Oh, we would just drop out then. Yeah, okay. We would return true way too often. Yeah, no, I think I was right here. Okay. Yeah, that's wrong. Hello from Instagram. I do indeed suck at programming. Yo, what's up? Welcome. Appreciate you stopping by. Well, this isn't right. We should be moving more than one thing. Try move walls up inner. Okay. So let's see. This function will get called. The robot's here. And this thing's above it. So the function will get called with this. That's where the function's being called first. Okay. So the function's being called with that, meaning that this character is this. So we store it, because it's a left angle bracket, and then we check the piece above it and the piece above it and to the right, because those would be the two things above it. So now that recursive function is being called. It was called with this, and now it's being called with these two things. So these two are being called with the inner thing. So this function is being called again with both sides. And then this side is being called, and it's going to look above it and to the right. And this one's going to look above it and to the left. Doesn't matter, they're checking the same thing. So we're going to have some duplicates to filter out. I don't see why this wouldn't work. Here's what we'll do. Vim Dave. Let's make Dave really simple here, because I think this is the problem. Like, I think we've isolated the problem. We have two things above it. Try the first move instruction. We can move, and all it did was move this one up, but it lost the other one. We should be moving two things there. What if we just do one move instruction? Yeah, we lost it. We pushed one into the other one, so we actually lost a thing there. How did we lose a thing? We can move. Moving 2, 6. Yeah, see, all we did was we moved 2, 6. So 2 is here. 0, 1, 2, 3, 4, 5, 6. So we moved the one that was here above it, but in the process, we lost track. Well, we just overwrote it. What we did is we overwrote 2, 5, and somehow 2, 5 just never got saved. It's not being called. Am I crazy? What's going on? Why are the inner functions not being called? I might be doing something just stupid, right? Am I blind? What's going on? And then print we can move. Am I duplicating the function? Oh my god, I'm calling try move walls up inner here, but that should be down inner. Oh my god, I just didn't rename the functions? I mean, that'll break things perfectly. Yeah, no wonder why nothing's being called in the right way. Yeah. Yeah. I just had the same functions. Oh my god, am I just stupid? I just had the same function name. Oh my god, I think that's it. I've been pushing off doing Advent of Code, but haven't decided what language to try it in. I'm debating on doing it in C or Java. Depends on what you know better. I'd personally reach for C, but I know for a lot of people Java might be easier. I want to understand code on a deeper level than being a web dev. Yeah, I mean, definitely try Advent of Code. Do it. Like, it's super fun. Sup, Dave Eddie? Yo, what's going on? How you doing? I swear to God, was that my only problem? That I just had the same function names and I just was being dumb about it? I still see some how do we get there's. But the simulation looks like it's working. When do we see those? Or is it just that? Oh, we're not seeing that. Okay, cool. Okay. Oh my god, this is cool to see. We broke it. 8898, that's not true. I mean, look at the map. The map doesn't even look right. The logic to push things down seems like it's slightly broken. It's cool to see, though. Yeah, the logic to push things down seems like it's a little bit broken. Oh, well, probably because I call it can move up. Well, it doesn't actually matter. It actually doesn't matter that we called it that. They won't run at the same time. What did I change with these functions? Did I change anything about this? I don't think I did. But let's just redo it because we know these work. Okay. Try to move out of bounds. Yeah, how are we eating Yeah, what happened here? Let's try to get our own thing to trigger this. I think we can do this, this, this. Put the robot here. Have the robot move right twice and then down. Yeah, look at that. So we start there. We move right, which displaces it, and then we try and move down. And it moves all of this stuff down. Why did that happen? I think my copying and pasting of code must have done something wrong. Well, yeah, probably because I'm calling walls up inner here. There we go. Okay. Still broke. I still push things outside. But that one was fixed. What happens here? Okay, where do we break? This all looks good. Okay. Super boring. Wondering if I should write like a validate grid function and I can just run it until the grid is invalid. Hey, there we go. It just ate that. I don't know why I did, but it just totally ate. Let's go right and then down. No, that worked. I don't know why it ate it. That's so weird. But once we figure that out, we're done. Yo, what's up, Eric? How you doing? Welcome to Twitch chat. Yeah, I'm dual streaming now. I'm becoming a big streamer over here. Yeah, thank you for popping in, man. That's cool. And yeah, I'm still going strong. Still going strong. We're on day 15. Everything else is done. Some of it was hard. I did submit some wrong answers. Day 13 was the hardest one so far. I popped off when I got it, and I even was like, I don't even know why this works, guys. Like, it works, and I can kind of explain it, but like towards the end, I was like, I'm done. How'd you like 14B? Okay. So, I don't have the edited video up, but the VOD is up. I'm pretty sure I said like 5 different times, I'm like, this is the coolest part 2 I have encountered yet. Like, hands down. I was like when I read the description, I was like, I don't even know what to programmatically test for. Like, I just have to like look. I have to like use my eyes. And I didn't even fully get it, but I started like staring at it. I felt like I was going crazy. I'm like, is a pattern gonna emerge? And I started to like see a pattern, and oh man, like during the video I was like jumping through a bunch of iterations, and I was like, okay, I kind of see something vertically here, kind of see something, and then like for a split moment it flashed. I was like, no way. Like, that was so cool. And then, of course, I completely overcomplicated in my brain how you would have done that. I was like, how do you even do that? How do you come up with this? And some of my chat was like, oh, start with that and then work your way backwards to like an unfinished state. And I was like, oh, well, that's actually very obvious. I don't know why. When you're 5 hours into code and your brain just stops working, I was like, yeah, but still, that was super cool. I have to say, that was my favorite part 2 so far. Like, they've all been really good twists, but that one, I was like, I like this one. I don't know, my favorite part 2 might have been going from 25 iterations to 75 iterations and then just like running out of RAM. I thought that was really cool too. If you think that's a cool part 2, you would love some of the shenanigans in 2019. I'm excited. Once I knock this out, I think I want to go through like from the beginning and just tackle it. Like, just, I've been enjoying these streams. It's been a ton of fun, and I have about 10 years worth of puzzles to catch up on. So yeah, I think I will. I think that sounds super cool. Yeah, that one was insane. I totally went to the Reddit afterwards and like did a quick search like to see if people made animations of 14B, and they did, and it did not disappoint. Super cool. I love it. That was an awesome part 2. Even this part 2 in day 15 is still really fun because it's double the width but the same height. So suddenly the logic for moving to the right or moving up is wildly different. And right now I'm in a situation where I'm just losing track of obstacles somehow, and I do not know how. So it's been fun to debug this. The subreddit is consistently full of excellent animations and diagrams. I know, oh man, I kind of want to throw in my own. Hopefully it's like the Reddit's still like bumping even when it's not December. I assume people are still talking about it and stuff. Because when I actually get some time, I want to do like an animation. I think day 6, part 1 and part 2, I have a couple ideas for that that I think would be fun. Dark Space says, you're going to love day 17, part 2. Oh man, I'm excited. I like day 15 because it's an interesting, complex problem, but it's intuitive to explain. Oh man. You know what? It's so funny. I think I said that at the beginning of the stream. I was like, visually, this is so easy to comprehend, but programming it has just been so dumb. And my brain's like going through all of my past knowledge where I'm like, oh, here's an open square bracket. I could push that onto a stack and then pop off the closing square bracket. I'm like, no, I'm just overcomplicating it. And then I look back and I'm like, maybe I should have overcomplicated it. I wouldn't have ended up with 4 different functions to handle 4 different cardinal directions. I wouldn't have try move walls up, try move walls down, try move walls left, and try move walls right. But here we are. 17B is a whole thing. I'm curious how you like it. Ooh, I'm excited. Yeah. And it's fun. I like when I do like when the part ones are like, oh, here we go, straightforward. Like it's still a challenge, but straightforward. And then part two is just like, oh yeah, we're throwing everything out that you've learned and it's going to be brand new. Yeah, we are somehow just, this example works. Oh yeah, dude. Don't ask me to explain some of my solutions, okay? Listen, they work sometimes. That's what I promise. So when did this start failing? Was it around iteration 100? I have to admit, this animation looks nice. Here it comes. Break. Yeah, there we go. It just ate it. Why did it just eat it? Okay. 194. Okay, so we have... Did he already eat it? He did. Okay. So the robot's there, then the robot's here. Here we go. This is the problem. Yeah, it's supposed to push down. Okay, so we're trying this. It's supposed to push these three things down. That's all it should have done. And what it did instead is it didn't push anything. It just overwrote this one. But knowing my logic, it probably did push them down and just lost track of one. That's what most likely happened. I wish more puzzles could be debugging is as easy as watching the output, but it's hard to build. Oh, let's see. Do you make a compiler for encode? I'm curious how you made the inputs. Oh, that's so cool. Oh my god, that's awesome. Heck yeah. And I agree. I love the visual debugging. Like, I mean, come on. Yeah, 13 part 2 was like really cool to have to debug that one. Oh, that's so cool. Here's the encode compiler, warning 2019 spoilers, and also some example inputs. Oh, that's so cool. I am going to copy this, and I'm going to write this down. I'm not going to go there, because I don't want to spoil anything yet, but I'm going to keep track of that. That's super cool, and super cool that you shared it, too. Yeah, go after you finish 2019, day 25. Okay. After 2019, day 25. Got it. All right, I should recreate this arrangement, right? It's like here. Yep, it is on the right side. We push down from the right side and that breaks it. Only on day 18, reading the problem made me want to die. Oh, hey, there we go. Look, we ate it. Cool, so we moved to the right. Now we're at the right. We're going to try and move down. We try and move down, and we lost it. Okay, this is nice. We have 2 moves that can trigger a problem scenario. That's very easy to work with. And it's going to be in try something. Try move walls down. Cool. So where we try and move the wall down, we are running into an issue. I know we call it can move up. I don't care. We can keep reusing these variable names. It doesn't actually matter. Oh my god, 2019 day 18 is inspired by Link to the Past randomizers? I'm so curious what that could mean. Oh my god, I love A Link to the Past, and I love randomizers. I've never played A Link to the Past randomizer, but I've done Super Metroid randomizers, which feels silly because I know there's like a combination Super Metroid and Link to the Past one, which would be really cool to learn. I also know there's like Metroid NES and Zelda NES randomizers, which is pretty neat. But yeah, that's, oh my god, that's awesome. It's inspired by it. That's sick. If you played Super Metroid Randomizers, the LT, oh yeah, that's awesome. I have to, yeah. Super Metroid is my game that I put on when I don't want to have to think. That and Super Mario 64, I put those games on randomizer, and I just don't think. I just know the movement, and I can just problem solve. I'm like, oh, I got this new tech. Okay, now I know how to get to this area of the map, because like you just kind of have all the movesets memorized. It's awesome. It's so much fun. Oh my god. They shuffle around the items, enemies, bosses. Okay, yeah, that's sick. I figured that's what it would be, but yeah, like that's, oh man, I should play it. I just don't know A Link to the Past like as well as I know, like, you know, Super Metroid, or at least like the maps and stuff like that. I've only played the Switch Zeldas. Like, don't get me wrong, they're great, but the ones on the Switch are, like, I'm thinking of Breath of the Wild, Tears of the Kingdom. They're great games. They're amazing games, but they're different than the rest of the Zelda games, and the rest of the Zelda games are super fun. All right, now at some part during this thing where we call to move, we are losing things. So if to move, echo, we will move to move. We're trying to move down, so now we're going to move 12-4 and 12-3. That is incorrect. We should be moving 3 things, not 2 things. That's what's happening here. I've done a run of Super Metroid where I stayed in ball form as much as possible, which meant I had to get really good at long distance horizontal bomb jumps. What was it? Was this a self-imposed limit? Why would you do this? Oh man, that's crazy. Yeah, no, there's like, oh man, you know, I instantly think of the what is it, trying to get over the moat, and you know, there's a couple ways you can do the moat skip, like the really good, like the very strict timing wall jump. But then I think of like the double bomb jump where you like do the bomb, do that, and then get like a perfect arc. I think I've executed that like twice in my life. It is not an easy thing to do. Self-imposed limit. It was fun. Yeah, that's awesome. That's amazing. Aneurysm would like to know if you had to shell out to anything yet for AOC and Bash so far. Yes. And let me remember what those were. It wasn't much. One point, I think the areas where I had to shell out, I could have done them without shelling out. Like I knew how, but I just didn't. So I think in the first one, I think I shelled out to sort. At one part to parallel, I forked and exec a whole bunch of stuff in the background, had them write out files with data in it, and then I catted all those files and piped it to awk to sum them up. Technically, I could have done that in Bash, but I did use cat and awk to get the final things there. So very, very low usage. In, oh god, was it day 13, the heavy math one? Yeah. In that one, I ended up shelling out to Python to use greatest common divisor, GCD, literally just to get that. I used that to find patterns, but I don't actually think I ended up using it in the final solution, but I used it as part of my problem solving. So I don't know if that counts or not. And again, I haven't edited these videos, I haven't rewatched them, so I could be forgetting something. But I tried my best to not shell out if I could avoid it. You can just chain the diagonal bomb jumps if you're careful. They're fun. That's crazy. That's awesome. Oh man. Yeah, I remember the first time, like, oh man, getting really good at just infinite bomb jumps in general, just getting the timing down. And once you have it, it's like, it's there. And then when you switch to a different Metroid game, like when I started playing Dread, I could not do it. You know, it's funny. Oh man, I'm getting off topic here. This Twitch channel that I'm on was actually my old channel from like years ago where I just did some video game content. I never wanted to be like a content creator. I just did it for fun, streamed to friends. And I'm pretty sure like one of the only existing VODs or clips from this channel is like me playing Super Metroid Dread a couple years ago, like beating it in Dread mode, like actually doing the Ravenbeak fight in Dread mode. The Dread mode thing was so much fun. Like the one-shot kill. Oh man, I love those things that feel like you're banging your head against something until you finally get it. Like speedrunning appeals to me. These puzzles, I mean, it's the same vibe. It's the same, like, it's frustrating, but like it's so rewarding. So it's just worth it. It's so much fun. Dave is using us to procrastinate. Listen, I am. I absolutely am. I'm procrastinating on so much stuff. Oh, man. You are a distraction, but I don't mind, man. Listen, you created the puzzles, so it's almost like, you know, when you're in school and you get the teacher a little bit derailed and you like get them to tell a story and you're like, this is so awesome, we're wasting time, teacher doesn't know. And then you get older and you realize, no, the teacher knows. This is how I feel. I'm like, you know what? Eric's jumping in, he's gonna distract me. He's like the teacher. It's like, fine, he wants to distract me. Listen, I'll get distracted. Also, I do let everyone else distract me. So I mean, there is that. Yeah. I don't actually know how I program when I have a chat. I'm gonna be totally honest. Like normally when I program, there's no chat. There's headphones and silence. So this is a different type of programming. Hang on, let me bring in the TV card. It's movie day. Yo, that's awesome. I have oh, you can't see it off in the background. I have the CRT TV, which I play the Super Nintendo on. So, I mean, we could already do that. Oh, someone rolling in a old CRT TV. That would be like heaven today. Incredible. Just trying to save some stars for himself. I love it. All right, so what's happening here? We will try to move these two. No, we should be trying to move three things. So, where do we push into to move? We push into them here. When we encounter a thing, we move into it. This should be enough. This should be enough. Okay, I must run. Good luck. Thank you. Appreciate it. Yeah, and don't worry, I'm keeping up on these streams. They are super fun, and I do have some ideas for animations and stuff. So I'll share it in the subreddit. I assume the subreddit's still fairly active, even when it's not December. So yeah, I have some cool stuff I want to work on. I really enjoy these, and just like yeah, dude, thanks again for creating them. Like literally, like you've made tens of hours, hundreds of hours of fun for me. So this is awesome, man. I appreciate it. All right, so what do we have here? 12, 4, 3. Okay, so this is 0, 1, 2, 3, 4. Okay, so we are not detecting this fifth one. So we move these two. These two get moved down here, but this one doesn't get detected. Why doesn't this one get detected? Because we are here, so we are checking down, and we are encountering a right square bracket. So when we encounter a right square bracket looking down, we call try move walls up. Well, okay, so calling the up variant of the function is probably not what we want to do. We probably want to call the down variant of the function. This is the danger of copying and pasting code. I think it's going to work now. I say that like I'm so disappointed. Hey, let's get rid of that sleep. Honestly, I'm glad you guys distracted me because it forced me to have to reacquaint myself with the code, and that's how I found the bug. So, like, let's not lose sight of that. It's done? Okay. So the final score of the larger example input is 9021. The box should look like this, and 9021. We got it. We got it, all because Eric distracted me. So, this is going to be a lot of output. Yep, that's not worth it. Let's just not even format the grid. Let's just do this, and let's go back to printing this out. Well, whatever. The printing was super ugly, but we got a number. I helped too. You did. It's so true. You guys really helped with distracting. But no, you were the one who called it with the wall up and wall down. Like you actually saw that before I did. So that's true. Y'all ready? Let's go. That's the right answer. You were one gold star closer to finding the chief historian. Oh, Eric, you just missed it, my friend. Oh, man. That's awesome. Nailed it. Easy. Easiest puzzle I've ever done in my entire life. I say that. Every puzzle's taking longer. This one took like 3 hours total. So, maybe not the easiest. But, no, this. Oh, my God. It's fun. It's fun. We're crushing it. This is awesome. Whew. GG, everyone. Nailed it. What do we have? Day 14. Oh, I didn't commit day 14. Must not have. Okay, what if I get at everything? Add day 14. No comma. And day 15. All right, let's push that up. All right, cool. So now everything's on GitHub if anyone wanted to look at it for whatever reason. I have no idea why. Get remote show origin. Is that it? Yeah, that'll work. Heck yeah, we nailed it. Easy, easy. Look at that. Day 15 done. Oh boy, what do we have left? 10 more days. We are more than halfway there. We are across the bend. So this is cool stuff. Nailed it. What's up, Tiger? How you doing? Oh, you sent that 20 minutes ago. My bad. Yeah, man, it was fun. It was a good time. And yeah, I'll be back to do the next one. I don't know when. No promises. My schedule's kind of just flaky. There we go. Oh, man. All right, well, thank you for tuning in, everyone. I appreciate it. We are knocking this out. Day 15 done. And it would have gotten done so much faster if I just didn't make all these mistakes copying and pasting code. So how fun is that? Remember, kids, always copy and paste your code. So dumb. Whew. All right. Well, I'm going to call the stream here. Thank you, everyone, for tuning in. Much appreciated. Going through the backlog. I got, I think day 6 might have been the last one that I uploaded. I don't remember, but I got fun videos up there, so go ahead and check them out. Yeah, that's it. All right, I'm going to jump off. Take care. See you, everyone. Have a good night.